Hello, dear students. Today we have Proposition 10 of Book 3. Proposition 10, Book 3. A circle cannot cut another circle in more than 2 points. One circle cannot cut another circle in more than 2 points. We're going to do a reductio ad absurdum. Here's our circle, and here's the other circle. I know it doesn't look like a circle, but the only way you can do this is to fake it with the drawing. Okay, so if you had a really warped imagination, you could say, yeah, that's a circle, and it cuts at more than 2 points, listo. Okay, so we'll say, all right, let it be a circle, and let it cut it at more than 2 points, okay? Let the red circle cut the green circle at more than 2 points, 1, 2, 3, 4 in this case, okay? You could do this thing any way you want. You could have it cut it at 5 points, but we're just going to have it cut it here. Okay, so now let's connect some lines here. Connect some points. Connect these 2 points and connect these 2 points. Where the circles cut each other, okay? Now let's take this line of the green circle. Okay, we're just going to call it of the green circle just to be strict. Now come over here. We're going to use this correlation of Proposition 1 of Book 3, that if straight line is bisected and another straight line drawn at right angles to it, that the center of the circle is necessarily on that straight line. Okay, that's a corollary. So let's do that here. Let's bisect this straight line. We know we can, given a line, we can bisect it. We proved that in Book 1. And we know that if we have a point on a line, we can draw another line perpendicular to it. We proved that in Book 1 as well. Okay, so let this be perpendicular. Let this be drawn through to the green. Okay? Therefore, we know that the straight line, the center of this green circle is on this straight line. Okay, let's do the same thing over here. This line within the green circle again. We're going to bisect it. And we're going to draw a line perpendicular from that point of bisection. We're going to draw a line perpendicular to that line all the way to the other side of the circle, the green circle in this case. Okay? Now, because we have a line in the green circle, and that line's been bisected, another line drawn perpendicular to it, the center of that green circle is necessarily on that line. But it's necessarily on this line as well. We already showed that. And these 2 lines cut each other only at one point, and that's here. So let that be the point. So the center of the circle is necessarily on this green circle is necessarily here. Likewise, we can do the same thing for this red circle. Let this line be in the red circle, and we just did that here. Same thing, just that we imagine it a little bit differently. Carry these through. Okay? Line within the red circle, line within the red circle. Bisected, drawn perpendicularly. Bisected, drawn perpendicularly. Therefore, the center of this red circle is necessarily on this line, and it's necessarily on this line. Lo and behold, it's that very same point of, they only meet at this point, so it's at, that's the center of the red circle, but it's also the center of the green circle. Now we have a serious problem. We've got 2 circles sharing the same center, but we know that 2 circles cannot share the same center, so it's both sharing and not sharing. Absurd. Therefore, it was false. Reductio ad absurdum, everything else was logical, so that thing we granted that we were not sure about, that thing we granted at the beginning from Mr. Smarty Pants, that 2 circles can indeed cut each other at more than 2 points, that which we granted must be false, because absurdity followed necessarily. Therefore, we have shown per reductio ad absurdum that a circle cannot cut another circle in more than 2 points. Thank you. Bye-bye.